All right. Looks like we're going to be doing Algebra 2, Lecture 927 and 928 today. That's OAS A2A12. The student will solve quadratic equations by setting the equation equal to 0 if it's not already set equal to 0. Factoring. So we'll set it equal to 0, we'll factor, then we'll employ the zero product property. In our cases today, A, that's the leading coefficient. This is A, B, and this will be C once I set it equal to 0. But A will not be 1, so I'll have to deal with that, and we're going to deal with it by today factoring out the greatest common factor. So A does not equal 1, the terms share a common factor, and we're going to factor that out. So here we go. We're going to take a look at what all that up there means. And I'll look at this and say, okay, 8x squared plus 48x minus 54, I'm asked to solve it. It's set equal to 2. I want to set it equal to 0. So I'm going to turn it into 0 by subtracting 2 from both sides. And that will give me 8x squared plus, oops, supposed to be a 2. 8x squared plus 48x minus 56, these are the same signs, so we add and keep the sign, is equal to 0. So I set the right side of the equation equal to 0. Now I'm going to attempt to solve. I see that my leading coefficient is not a 1, so I'm going to see if I can factor an 8 out of all of these. And I see that 48 is divisible by 8, because 8 times 6 is 48. And 56 is also divisible by 8 because 8 times 7 is 56. So I'm going to write down the common factor and then term by term pull that common factor out by dividing. So if I divide this by 8, I'm going to wind up with x squared. Plus, if I divide this by 8, I'm going to wind up with 6x. 48 divided by 8 is 6x. Minus, if I divide this by 8, I'm going to wind up with 7. Now, just left the plus or minus signs in place. So that's my first step, is to factor out the common factor, and then I'll be left with a quadratic trinomial that we will factor using the same techniques that we've used in the past for factoring the quadratic trinomial if it's factorable. And today all of them will be, I think. We'll see. I open up two sets of parentheses. Oops. And then I take the square root of this one. Now my A is 1. So I can go ahead and put the square root of this one here. I'll pull that 8 out. Don't let it disappear. It's still a factor. X and X are the factors of this one. And I'm looking for factors of 7 that will add or subtract to give me a 6. And that would be 7 and 1. 7 is prime, so it only has 2 factors. If I add these together, I'm going to get a positive 6. So the signs of these two have got to be positive 7, negative 1. Now, my last step will be to employ the zero product property. The zero product property says if this times this equals 0, then one of these three has got to be 0. Well, it can't be this one because that one's 8. But this could be 0. Or this could be 0, depending on the value of x. And then I solve these. Well, I subtract 7 from both sides, and x would be negative 7. Or, in this case, I add 1 to both sides, or x could be 1. Those are my solutions to this equation. That means if I put in a negative 7 right here and do all this arithmetic, I'll get 0. Or if I put it into the original equation, I'll put it here and here, I'll get 2, because this was before I subtracted 2 to both sides. So these are our solutions, and they're often written in set notation. Negative 7, 1 would be one way of saying it. The set whose members are, negative 7, 1. And you might see it written like this because the order of the elements of the set doesn't matter. The order does not matter. So it could be written like this, your solution, or like this, or like this. Okay. So there we go. We solved one by doing this. We set the equation equal to 0, we factored out the common factor, and then we employed the zero property, the zero product property. A wasn't 1, so we had to factor that out first. Let's do it again and see what it looks like here. First thing I want to do is set this equal to 0, so I'm going to add 4. This will give me 2m squared plus 6m minus 82 is equal to 0. Okay, oh, that's not 82. I'm an old man, I can't add or subtract. These are different signs, so I subtract. 84 minus 4 is 80, not 82. And I keep the sign the one with the greater absolute value. And now I'm going to try to factor. I notice that A is not 1. So I'm going to try to factor a 2 out of everything, and I see that I can because all of these are even. So I'm going to say 2 times the quantity, m squared, plus 3m minus 40. I pulled a 2 out of every one of these terms by dividing each term by 2. Divided that by 2, divided that by 2. And if I distribute this 2, I'll get right back to where I started. So I haven't changed its value. I've changed it the way it looks. And now I'm going to try to factor this. And employ the zero product property. Here we go, square root of this one here and here. Notice I brought this 2 down. Square root of this one here and here. Factors of 40 that add up to 3. 2 and 20 won't work. 4 and 10 won't work. 5 and 8. 5 times 8 is 40. And 8 minus 5 is 3. It doesn't matter where I put the 8 and the 5. What matters is these must add up to positive 3. And the only way that can happen is if the 8 is positive and the 5 is negative. Now I've got it factored, and I employ the zero product property. The zero product property says if these 3 things are multiplied together and I get 0, one of them has to be 0. This one can't be, but this could be, and this could be, depending on the value of m. So I'm going to say, well, m plus 8 could be 0. Or m minus 5 could be 0. Solving this by subtracting 8 from both sides yields m equals negative 8. Or adding 5 to both sides of this equation, m equals 5. So those are my 2 solutions to this original quadratic equation. And again, it could be written in set notation. The set whose numbers are negative 8 and 5, or it could be written like this. The order of the solutions, the elements of the set, does not matter. Okay. And now I'm in a good place to check to see if I got those right before I go any further. 927 and 928, I think. Yep. So let's see, number 1 is 1 negative 7. There we go, they wrote it like that. And number 2 is 5 negative 8. They wrote it like that. But this, or this, they're all 3 correct. Just different ways of saying the same thing. Let's take a look at a couple more, and then you can start your assignment. I look at this, I want to set this side equal to 0, so I'm going to subtract 4. Rewriting is 6n squared plus 18n plus 16 minus 4 is 12 is equal to 0. I see that my leading coefficient is not a 1, so I'm going to try to factor it out, and I see that I can. N squared plus 3n plus 2. I divided each one of those terms by 6 when I factored it out. And if I were to distribute that, I'd get right back where I started. So I haven't changed it. I've changed the way it looks, but I haven't changed the value of n there. Now I'm going to try to factor this quadratic trinomial. 6 doesn't disappear, it's still a factor, but we're trying to factor this variable expression. We take the square root of this one, put it here and here. Factors of 2 that add up to 3 would be 2 and 1. 2 only has two factors because it's prime, and they will add up to positive 3 if they're both positive. So I've gotten it factored, and now I'm going to employ the zero product property, which says if you have a bunch of stuff multiplied together and you get 0, one of these things, their factors, has got to be 0. This one can't be because it has a value of 6. It's a constant. But this could be. It's a variable expression, and it could be 0, depending on the value of n. And this could also be 0, depending on the value of n. Now solve, subtract 2 from both sides will yield n is equal to negative 2. Or n is equal to subtracting 1 from both sides, negative 1. Those are our two solutions that will make this equation true. If I plug in a negative 2 here and here, do the arithmetic, I'll get 4. Or I could plug it in here and here, and since I've subtracted that, I will get 0, depending on where I plugged it. And these solutions could be written in set notation. Negative 2, 1, negative 1. It could be written like this. The order of the elements of the set, the solutions, doesn't matter. This is not an ordered pair. It's a set of solutions of the equation. Okay, so there we are. Set the equation equal to 0, factored out the common factor, factored the resultant quadratic trinomial, employed the zero product property, and then wrote our solutions by solving these two and recognizing that there's more than one way to write your solutions that's acceptable. Okay, we'll do one more and you guys can get started. Here we go. I'm going to add 3 to both sides to set this thing equal to 0. Rewriting the equation is 8r squared plus 72r plus 64. 61 plus 3 is equal to 0. I'm going to see if they all have a factor of 8 and factor out the 8 because this leading coefficient is not a 1, so I've got to deal with that somehow. And I see that all of these will divide by 8, so I'm going to factor out the 8. R squared plus 9r plus 8 is what I'll get if I divide each one of these by 8. Factoring out the 8 is equal to 0. Factoring this quadratic trinomial, this 8 comes down. Square root of r squared goes here and here. Factors of 8 that add up to 9 would be 8 and 1. Numbers that I can multiply together to give me 8, and those numbers will add up or subtract to give me 9. In this case, they add up. The factors of 8 are numbers that multiply together to give me 8. Now I want them to add up to positive 9. So the only way that I can get these two numbers to add up to positive 9 is if they're both positive. It doesn't matter where I put them. I could put the 1 here and the 8 here. What matters is they add up to positive 9. Now I employ the zero product property. Either this could be 0 or this could be 0 depending on the value of r. This can't be because it's a constant. So I'm going to say r plus 8 could be 0, or r plus 1 could be 0, and I solve. R equals negative 8. Subtracting 8 from both sides, subtracting 1 from both sides, r is equal to negative 1. Those are our solutions. And we could write those in set notation as well. The order of the elements of the set does not matter. This is not an ordered pair. It's a set. A set whose members are negative 1, negative 8. And those are the 3 ways we could write those solutions. And I'll check and see if I got those right. Negative 1, negative 2. And negative 1, negative 8. All right. So there we go. We just solved quadratic equations by setting the equation equal to 0, factoring and employing the zero product property. A was not 1, so we had to factor out a common factor first. You can do this.